Hi guys, my name is Steven. I have to tell you that there's been a corporate shakeup since my last video. The finance guys from corporate told me I have to lay off my entire legal defense team. However, they told me I can hire contractors instead. So I'd like to introduce my new contractors whose job titles are Corporate Leverage Acquisition Experts. So let me introduce Maddie and Carl. On their behalf, I'd like to welcome you back to my calibration channel. One of the cool things about making these videos is that every once in a while someone will comment. One of the comments came from a friend of mine named Andy. We exchanged emails and I asked him could he suggest a topic that he'd like to hear more about. Here's what he said. He said, maybe do a talk on how alarm limits are set compared to process limits. Are these randomly set, or is there a methodology on how alarm limits are set? Now, since this is right in line with what I've been thinking about, I consider this a great question. So let's get into it. To do that, I want to create a structure within which I can talk about Andy's question. I can't claim that I'm going to answer it perfectly, but I think I can move us forward. And I'm going to do it in only 4 slides. So let's go. Here's slide number 1. By the way, this is rendered on some extremely expensive graphic software. I've just represented a particular measurement made within process limits. You may have only one process limit, but I'm assuming you have some, or else what's the point of making measurements? In other words, you have a critical value that you're concerned about. That's why you make a measurement. In this case, this measurement is represented just like a point in geometry. It has no thickness, it has no size, it just exists. This might be a good schematic for the thousands of measurements you make every single day. Okay, to move forward, let's go to slide 2. Now, all I've done here is take that one single measurement point and represent the measurement region that lives around it. I've said before, and I'll say again, all measurements have an associated uncertainty that attaches to them that we cannot remove. In this particular case, I've modeled the uncertainty region as one that has 3 different components. I know there's 3 components to this uncertainty because there's 3 dimensions to the shape of the uncertainty region. Now this is a model, and I'd like to pay homage to my hero, George Box. It's George Box that said, all models are wrong, but some are useful. Now I know this model is wrong because given any particular measurement, you can never be sure of how many different kinds of contributors there are. So I've just drawn in 3 contributors so I can have a spherical region that surrounds the measurement. We'll never be sure of exactly how many of these regions there are. But by creating a model, we can at least move forward, even if it's not perfect. And as I've said, it can never be perfect. One more thing about our model. The closer we get to the center of this data, the closer we are to the best representation of that parameter at that particular time. There's no such thing as a perfect measurement. There's no true values. And as I've said before, getting distracted by talking about true values is just going to take away energy from doing the kind of analysis that will help us answer Andy's question. So another way to think of the regions that live around the best representation of this value is just to think about it in terms of probability. The probability of getting a measurement way outside on the edge of this region is low. The probability of getting other measurements that are close to the center is very high. Okay. So far, we've only modeled one particular point and talked about its uncertainty. Suppose we're talking about a batch process where we make many measurements over a period of time while we're doing a batch. In fact, if this were a fermentation batch, we might have to draw 6, 12, or 18 different parameters. So I kept it simple. But you can see there's a beginning of the batch and the end of the batch. Now you'll note that this parameter never went outside one of our process limits during the entire time of the batch. So if you consider this only on a pass-fail basis, this batch is good. No more discussion necessary. However, we already agreed that every single measurement ever made has associated uncertainty. So here what I'm doing is drawing in the uncertainty that's associated with the parameter that we were looking at during this batch. Again, the parameter never exceeded one of our limits. The uncertainty did. It's right up here where the question mark is. Now this is a big question mark. The only people that can confront this question mark is the people that are accepting the batches. The question is very simple. Is the measurement system that you employ to accept or reject your batches adequate to protect you from the risk of measurement uncertainty? Every organization has to answer that question for themselves. No one else can do it for you. So let me just reiterate to make sure we're clear. This batch passes on a pass-fail basis. It may or may not pass when we consider the uncertainty that we know is attached to measurement systems. So let's get as close as we can to answering Andy's question in less than 10 minutes. I can think of three methodologies that apply here. The first one is the methodology of estimating measurement uncertainty. That certainly is central to the question of how do we set and defend our process limits or any alarm limits we might want to talk about. I'd like to point out that in each of these cases, the process limit itself has uncertainty because it's defended by measurement. So even when we display the process parameter as something that has uncertainty, we need to also remember that the process limits have uncertainty too. It comes from the same place. After you've assessed the measurement uncertainty of your process, you might want to consider improving the process control that you're using to create your batches. In other words, if you keep the process parameter from getting as close as it does right now to your process tolerances, your chances are improved of making an acceptable batch. That's just engineering. There's another methodology that exists in the background here. One of the best ways to set process limits is to use control charts. Control charts couldn't exist without process limits. That's how you know if you're in or out of control. Those process limits are created using an agreed upon methodology. You might want to investigate this methodology and see how it applies to the processes that you've inherited. One great place that I would suggest you start is a website called spcforexcel.com. This is a great group of people who put out a monthly newsletter that I always love to read. They're one step that you could take towards validating your alarm limits or process limits. Check them out. In the meantime, on behalf of my corporate leverage acquisition experts and myself, I'd like to thank you very much for the time you spent watching this video, and I invite you to stick around for the other ones that I'm going to produce. Thank you.